we're hoping the information today is going to be useful so that you can learn from it, and it's really the greater good of the industry. So this information is not a members only, this is going out to a much broader audience, but we're going to be covering today in the beginning, and I created this crazy title. I get thoughts, my most creative thinking I think comes to me at about 1 a.m. to 3 a.m. So this came to me of, I have this concept that I want to share with everyone, and really starting from in the beginning of all areas of dietary supplements and kind of moving throughout the year with our webinar series to kind of touch different topics. So in the beginning, go ahead and start the slides, has several different meetings. So what I'm thinking on, what I was thinking when I created this concept and ideas in the beginning really touches on, this is our first webinar of the year for the UNPA regulatory series. And in the beginning, we did not have a typo in the title. For any of you that are looking at that title page and all the announcements that were going out, that capital E was intentional. So Evelyn thought of this concept and she threw it out there. I don't know if she knew I was going to change the slides for it, but in the beginning, the BE, the capital BE, is really referring to bioengineered foods. And a lot of the discussion today and our subject matter experts are going to be talking to you about GMOs and bioengineered foods and the labeling requirements for these products. So we'll be talking about monitoring as well as labeling. And also in the beginning, we have to think about quality. And I have been in the dietary supplement industry now almost, well, 25 years, I'm crossing over. But in the beginning, really reflecting on the quality of the dietary supplement products and any product, but this will be focusing really on our products and the ingredients that we utilize. But quality begins at the supply chain. And for many of our dietary supplement ingredients, it also might start at the dirt because a lot of our ingredients are going to be botanically derived. So we're going to go again back to in the beginning, starting with the quality, the supply chain, and the supplier. All right, I use this slide when I present outside of the membership, but this slide, if you don't see your logo on here, don't panic because I have actually a series of slides that I utilize for all of our members will be shown. But on this, I usually am presenting who is UNPA and what are we, who are we and what do we provide for the industry? And within this slide, we have many of our larger brands, contract manufacturers, raw material suppliers, et cetera. But I state that we are the greatest collection of brilliant minds and we're collaborating for the greater good. So with this, I feel that's really the mission, or my mission is really helping everyone understand these new things that are coming at us from regulatory and compliance concerns. So this presentation and webinar is also going to be just that. We're going to be using a lot of members that are subject matter experts, and we're going to cover 90 minutes in this webinar. So I hope you're available for the entire 90 minutes because each section is going to be very valuable and useful information. But we have 4 informative subparts, and you saw in the announcement what those topics will be. But we're going to be covering that from 6 subject matter experts. And hopefully with time management, we can have 15 minutes of Q&A at the end. I do encourage you to use the chat function of Zoom. You can either send those questions to everyone, or you can send them directly to Linda, and Linda will help us with that moderating at the end. If we run out of time for question and answers, we can stay on if anyone is available, but most likely we'll just forward those questions to the appropriate subject matter expert and you can work with them directly. Okay, within this, I'm hoping we can give you what you needed to know on each of the topics. The challenge we have is we're covering very complex topics and we're only doing 15 minutes per topic. So really, I encourage you to work with the speakers and the subject matter experts after the program. If you need additional help or information, they're going to be the best bet for that. We're going to cover as much as we can and give you what you need to know and understand what the roles and responsibilities are for you in the dietary supplement world and as a company, brand owner, contract manufacturer. So here's my midnight ideas. This is how they come to me. It's like, Shazam, I've got this idea. So with this idea, my purpose and objective, when I was thinking through this and pulling all of my friends and colleagues together, all the smart people in the room, is these are areas I feel like we all need to think about and consider as an industry, because regulations are changing and everything is changing. The world is changing, but within this pandemic time period, there's been some new changes and updates that we all need to be aware of. And I think we're also going to need to look at our quality systems and our regulations. Our regulatory team is going to have to evaluate. We might need to modernize some of the systems within our organizations as appropriate once you hear some of this information. This is going to be applicable again to our manufacturers, our brand owners. A lot of it's going to flow down into the raw materials supply chain as well. So looking at GMPs, we've always focused on GMPs, of course, but we now, throughout the pandemic, we also need to start thinking about FSMA, the Food Safety Modernization Act. There's a lot of regulations that were implemented and signed, and now all the compliance dates have been reached throughout the pandemic. So once FDA does hit the ground again, they're going to be looking at the investigations differently. And I want you to be aware of that, and especially when it's related to GMOs and bioengineered foods. When we talk about FSMA, we're really talking about what are those ingredient risks. And I'm going to show you in the next couple of slides. Looking at ingredient risk really means we've been conscious and aware. You're here because you're a responsible and ethical company, and you are concerned about some of these changes. So when I say risk, it's really looking at ingredients in a different light, because we've always been evaluating them in our quality systems, but just looking at it under a new perspective. So I'm a regulatory nerd. You've all known that for a few years now, but historically, when we talk about specifications, we're talking about when we're talking about quality in the dietary supplement world, we're really bumping back into our 111s when we're talking about specifications. I'm going to throw in a couple citations here and there throughout the presentation, remind you where we're looking at in the regulation itself. But establishing a spec is found here in 21 CFR Part 111.70. And there are 5 required elements when we talk about a specification. So as a former investigator, I know that specification sheets at times are multiple pages and you have lots of details on there. However, the FDA investigator doesn't care about a lot of that information. What we were trained to look for were these 5 elements. So I call them the big 5: identity, purity, strength, composition, and limits for potential contaminants. Those are the items that you must have on that specification sheet. And I recommend that you put them in a header, because again, the investigator that doesn't understand our industry, our products, or our processes, they do know how to look for these keywords. So moving on, we are going to focus primarily on the limits for potential contaminants. That's really what this presentation is emphasizing when we move from front to back. But consider the risks of those ingredients. And I put the terminology here, risks and hazards, that's shifting us into that FSMA language. But typically in our quality systems, we were always looking for heavy metals, pesticides, and microbiological contaminants. We're going to move through that today in the presentation. And heavy metals, I put in parentheses here. This is really APA documentation, but FDA investigators were looking for these specific heavy metals: arsenic, cadmium, lead, and mercury. Those are typically what you're going to find in plant products that are going to be absorbed from the soil. Pesticides that might be applied to the product, or something that might be harvested nearby, creating some drift. Okay, so here's some more regulatory nerd stuff. Within the dietary supplement regulations, 21 CFR Part 111, dietary supplement GMPs, potential contaminants are mentioned 3 different areas when we're talking about our dietary supplement products. The components are covered, in-process materials, and finished products. You can be cited by the FDA for all of these areas if you don't have appropriate management of those products. So components is covered under 111.70B3, in-process 111.70C1, and finished products are under 111.70E. Now, you might also see citations on 483s, which is your inspectional observations and the deficiencies found by the investigator. And this second one that I listed here is QC review and approval of the supplier qualifications. So under the context of what we're looking at today in this presentation, think about these 2 citations if you need to go back and review, because those are likely where you're going to see some information. So here we are under FSMA, and again, all the compliance dates have been reached during the pandemic. So now FSMA requirements, I want you to just reframe what you think of our quality systems under these new parameters. Essentially, what FDA is looking at and looking for is, from an ingredient standpoint and from a finished product standpoint, we need to look at, say, what are the hazards reasonably likely to occur? Now, remember when I said hazards previously, we're talking about anything that was in our quality program prior: heavy metals, pesticides, microbiological contaminants, or any chemical hazards or physical hazards. Who's controlling the hazard? How is it being controlled? And that means you need to know specifically about their process. And what are the verification steps that you'll be conducting to ensure that those hazards are truly being managed and that they are they're adequate for the system that we're speaking about? So here's a question for all of you. I hope this makes you laugh, although I can't hear it because you're out in their Zoom world with mutes on. But when you are talking about how you qualify and utilize a raw material, as an former investigator, and even now in my career, I've heard many companies, and I'm sure if we had hands raised, that say, how do you manage your release of raw material? What do you do? What is your process or quality control before it enters the manufacturing system? And most companies are going to say the same thing. They're going to say that raw materials have a test and release process, and that's how we do it in the supplement world. And that's true. It's a standard business practice. But in reframing the language, we need to understand that FDA is not going to approve of this answer, because test and release is not an appropriate preventive control. It's a verification step. So just something to think about. The correct answer is going to be, you're going to use supply chain programs, which is found in 21 CFR Part 117, subpart G. Now, supplements are exempt from that section, depending on the type of operation you have. However, this is really the new and modernized version. And you have to remember that your raw materials or any food product that you're working with is covered under food regulations. So that would be 117. Once you receive it inside your facility to use in it as a dietary supplement, now you're going to be back under those specification, 111 specifications. So with that, I'm going to pass it off to the first speaker. We have, actually, I'm going to do an intro first. So Holly Johnson is going to do our first speaker. Holly, you all, I'm sure, know and recognize Holly from APA. APA is one of our sister trade associations. We work very closely with them. After Holly, she's going to cover good agricultural practices and some valuable resources from APA. Then we have Stanley and Allison. They're going to speak with us from QAI, a division of NSF. They're going to just share with us some of the areas on organic processing and some of the challenges that you might face and how to evaluate those products. Then we're going to move on, and Marcia and Nate from Food Chain ID will be speaking with you, and they're going to share information related to GMOs. And this is where we're kind of shifting into what to think about for those botanically derived ingredients, how to manage GMOs, what is a GMO, and then how to monitor for them. And then we're going to wrap it up with Evelyn. Evelyn Cadman is a member as well. She's with FDA Compliance Simplified, and she's going to share with us the information related to the new bioengineered labeling requirements. And that is going to be super valuable because the compliance date, it was in January of 2022, excuse me. So this is going to be something you need to start considering with your products. All right, now I'm going to pass it off to Holly, and we're going to listen to her brilliance. Holly.
Wonderful. Thanks so much, Larissa. Was my share successful? Can you guys see my screen? Okay, great. Thanks so much. Again, thanks to Larissa and Lauren and Linda and the UNPA for inviting me today and putting on this great workshop. I'm pleased to be here with you. I'm Holly Johnson. I'm an ethnobotanist and pharmacognosist and currently serving as the Chief Science Officer for the American Herbal Products Association. So we're going to talk about a couple of things today. And again, Larissa invited me to kind of, share some of the resources that we have at APA that are available to the public, not members only, and with you guys, and also just kind of tee up the experts that we have for the rest of the day. There's, again, so much to talk about. I'm going to be really conscious of keeping my things short. But again, we're going to talk today about botanical raw materials and just kind of best practices for maintaining a healthy herbal supply. I can't resist using large images. This is a really cool favorite herb called maca, you might have heard of, and someone harvesting it, wild collecting in the highlands of Peru. Okay, so GACPs, this is something you guys have probably all heard of. And in the context of, just generally. So these are good agricultural and collection practices, and there's many authorities throughout the globe, really, that have established these types of best practices. So one that's been known to many of us for about 20 years is the WHO guidelines, and these are specific to medicinal plants, very well thought out. Also, the European Medicines Agency, the EMA, has a document that's similar. Again, they refer to starting materials of herbal origin. We have to think a little bit about, you guys, almost all the food we eat is of plant origin, or is a botanical, right, in some way. But again, these two documents from WHO and EMA, and as well as the APA document, really focuses on the plants we use in the dietary supplements trade, essentially. So APA put together a working group, and again, in the presence of the WHO document and others, we decided that at APA that we should kind of collate this information and really make it really accessible to our members and to our community here in the United States, and kind of incorporate different sources and such. So this was published in 2017, and it was graciously endorsed by UNPA, as well as some of our other sister trades that are related to the trade of in herbal products. So you'll see here what we've got, and these are all available on APA's website for download. You can go there. You don't need to be a member. You may need to sign in. But again, this is a series of documents. You can get the entire guidance document here, or a zip file, and that's the web address there on the bottom. What I want to show you is a little bit, kind of just a look inside the document. So the document's got a bunch of different sections, but two of the sections I pulled out to kind of give you a closer look at are the cultivation and the wild collection sections. I'm not sure why, maybe because I just chose those two, but I'll show you the list later of all the sections in the whole document. But when we talk about cultivation, so there's the way our doc is set up is there's a general guidelines section, and it goes through, or a general guidelines document that has many sections. And then within the cultivation chapter, there's these 5 sections. So it goes through everything from, the propagation material and the seeds. And I know that sounds silly, like, okay, we just got some seeds. And again, there's organic, this kind of considerations. But something interesting, you guys, it really is important. And again, many of you on this call are not farmers, but even farmers who really, are great farmers and know their stuff, sometimes get bad prop material and bad seeds that may not be the actual species of interest even. So this is crucial. And then other kinds of things that you'd like to make sure that your cultivation supplier is doing correctly in terms of soil characteristics, water quality on the site. Doing a site location and a site history is really important, as some of our friends will talk about organic later, we'll touch on. Also fertilizers, irrigation, crop maintenance, and protection. So these are just the different sections in the chapter on cultivation. And then here I'll show you what we provide is these assessment tools. So these are actually like, this is set out in kind of a general checklist type way. So you could go through here and say propagation material. You've got some criteria, and then you can check either it meets, partial, or deficient. And this is kind of a general template that APA provides. And it's really the basis. I mean, it can be used as is, but it's also the basis for many companies to kind of refine their own qualification program when you're going to qualify a new supplier or an ingredient. You'll see the level of detail here is pretty extensive. Going into the propagation material, the cultivation site, I just took a little snap from the worksheet there. I wanted to show you one other section, just so you kind of get an idea. I think there's 12 sections in the whole document, but the other one is wild collection here. And something we think about too, this is called good agricultural and collection practices. Increasingly, plants in the wild are threatened, right? So we have to think about if we're going to use a wild collected species. Much like the maca that I showed earlier. But so this is just an example of the different sections that are in the wild collection chapter of our GACP. So again, it starts with permits and permissions. There's collections on public and private lands, collection site characteristics, sustainability factors, and habitat stewardship, and identification. Is the collector skilled enough to actually identify what they're collecting in the field? So these are huge things where you can qualify your supplier. And this trickles down to how does the supplier, if they're a wild collection, maybe distributor, how do they qualify their individual collectors and assess their skills? Those are really important questions to ask. Again, here's an example of kind of our assessment tool in the wild collection chapter. You'll see here we go from permits and permissions down to kind of some information about the collection site, et cetera. So you get the idea of kind of how the GACP document goes. One thing I did want to point out is there's this sustainability section, and APA's been on to stewardship of the land, especially for wild collected plants for decades. And just to note that we are now, this is section here in wild collection is about sustainability and kind of habitat sustainability. But really there's sustainability parameters that could be asked throughout all kinds of other places in the assessment. So we're actually in the process of revising now and kind of adding sustainability questions to each and every one of the sections, not just wild collection. So again, here's all the categories. Excuse me. Here's all the different chapters, I guess. So I just showed you this, a thing from the cultivation assessment tool and the wild collection assessment tool. But we go through, general operations, botanical identity and quality assessments. And these are all have kind of an explanatory chapter and then an assessment tool, much like the one I just showed you, that go with each and every one of these individual chapters. So a really complete and kind of user-friendly document, and also able to be adapted in your own companies and your own uses. We also have some educational tools. I don't think we're going to be able to talk about pyrrolizidine alkaloid contamination today. We could do a whole nother seminar on that. But again, we keep adding kind of appendices and chapters to this GACP document as they become relevant in regulations, and the PAs, the pyrrolizidine alkaloids are coming down the pike. Okay, here's just an example of some of the appendices we have. How do you know if your farm is exempt from Part 112? Food facility, some kind of regulatory explanations here, and then down to our latest appendix, Appendix 8, which has to do with those toxic alkaloids I just mentioned. So this is a really cool resource, you guys, and hope all of you guys go on the website and download it. Here's the website, but you can just go to appa.org and find it quite easily. And please email me if you have any questions about this. We really want advice on it. We know we're in constant continual improvement. So any advice you might have on how to improve too, or things that might be missing or such, we'd love to hear. So like I said, that's kind of a general template, right? And many of our member companies and people I work with have taken that kind of skeleton and then really transformed or developed their own standards. Megafood is such a company. They're just, they've developed what they've called their healthy farm standard. And so this is the way they've developed. It's very extensive. And this is a way that they're qualifying their small farms, mostly domestic farms, actually. And so you'll see down here the 3 bullets. The minimum requirements are in these 3 areas: building the soil, conserving resources, water, pollution, et cetera. And they go into farm management and thriving workers and kind of the social aspects. And that, is based on their company's mission and policies. But again, just to point out that what we provide at the GACP is very modifiable, and many companies are doing all kinds of interesting things to qualify their suppliers. One thing that won't probably be talked about the rest of today, and I didn't see on Larissa's list, and this is not US regulation. This is actually international treaty. So the Convention on Biological Diversity, the CBD, you guys, this is what we all used to call CBD before hemp burst onto the scene a few years ago. This is the CBD. And basically this is an international treaty that 174 countries are signed on to. Sadly, not the United States. So we are not under obligation here, but it's important. And just something I wanted to mention, that it's not just, contaminants and such that we look for when we assess where we're going to get our herbs. It's also, are we, in violation of any local or international type of regulations and laws. So this is something we talk quite a lot about in the APA Sustainability Committee. Sorry about all these words. These are just kind of the top bullets or goals of our Sustainability Committee, but we're doing some great work there. We've invited UNPA members to participate from time to time and really appreciate all the input. But yeah, it's sourcing botanical raw materials is a major point of discussion and such there. What I wanted to point out is that we made this table in the Sustainability Committee and kind of looking at the 3 different sustainability parameters, but really here to illustrate to you guys all of these different certification standards. We're going to hear later about non-GMO and, just the organic USDA organic standard. But there's all kinds of these different certifications that, again, if you're looking to source an ingredient, having that ingredient certified or the supplier in one of these types of certification systems, in addition to organic and non-GMO, they have different foci. So I just wanted to point that out. Oh, and then highlight one of them, the Fairwild. They are UK based and they concentrate on wild collected ingredients. You can go here, you can click, this is a snap from their website and look at all the ingredients. So again, in sourcing, sometimes when you've got certified ingredients, such as organic or non-GMO or whatever else, they've already gone through a lot of the trouble for you guys of asking some of those assessment questions that I showed in the assessment tool. So good places to go to. Here's a couple other resources outside APA that I wanted to point out. The Appalachian Beginning Forest Farmer Coalition here in the United States. And again, I think most of you guys are probably aware that there's been a big, supply chain delays and such with getting your freight over the sea and sometimes over the air. And so domestic supplies are becoming much more important and valuable and desired by brands. If you can get your herb that was sourced in the United States, this seems to be beneficial for a few reasons. First of all, they should have to have, if they're cultivating, complied with all the EPA regulations about pesticides and contaminants. And then also just the shipping nightmares. So anyway, this is a good source for domestic supplies of forest grown things. There's another program, similar forest grown verified program in Pennsylvania. I won't hit on that too much. But again, when we look at this huge list of things that you think about when you're assessing risk in your supply chains, there's all kinds of considerations, right? Like I said, just mentioned a little bit about domestic versus international. Your risk goes up the farther that you are away from your supply, right? Questions I always ask is, do you know your farmer? And not every company needs to know their farmer, by the way. You don't need to. That's why there's really, really prominent ingredient companies and this type of thing, because the ingredient company has done that work for you of knowing their farmers. So, not every company needs to know their farmer, but they should know their sources pretty intensely. And so here's some of the considerations. And, Larissa just mentioned a few of these. And some of our other experts will dive into some of these later on. But I think what I wanted to point out is just, again, back to APA resources when you're thinking about assessing your risk and setting specs and sourcing and supply chains. So APA has a variety of guidance policies. Here's an example of one for heavy metals. And you can see too, we say where companies choose to establish specifications or make hazard determinations. So this is critical. You don't have to set specs for each of these if you have assess that there's no risk for that. So I think Larissa and others will talk more about that. But again, this is just a snapshot from our metals guidance policy on what we think are reasonable for the limits or specifications that you might want on your materials. Here's another snap from our microbial load or our microbial guidance policy. And I just wanted to point out too that there's a difference between dried unprocessed herbs for use as ingredients, and then here powdered or soft extracts, and the levels of these microbes that might be allowed is different. All of these policies are available on our website. We have a whole slew of guidance policies, including other things that might be relevant to risk assessment. And again, risk, I think to me, it covers a lot more than just a hazard linked to public health or to health, right? So CITES, again, another international law that you might need to know about to mitigate your risk if you're using a CITES listed plants in your formulas. So here again, just the kind of a snap of the top of our list of APA guidance policies. You'll see there's metals, micro, adulterants, all kinds of things here. I wanted to also give a call out to our great friend and colleague, Roy Upton, over at the American Herbal Pharmacopoeia. His monographs are just an excellent source and resource for looking into supply chains and really important quality or characteristics when assessing risk. You'll see I grabbed his table of contents over here for this. this history and identification, really great, but the commercial sources and handling, where it talks about issues that are specific to cultivation of this particular herb, et cetera. So again, just a great resource to help in your establishing your supply chains. Also wanted to mention a couple other APA resources that are related to botanical raw materials. We have a series of sustainable harvest brochures. And again, this is focused on native North American herbs that are wild harvested. We, about 20 years ago, did the first one, which was ginseng. And I think you guys know American ginseng is quite highly regulated with some special things for that species. And so we got this out. These brochures are really targeted towards actual collectors out in the field. We've also had them translated into Spanish, as a lot of the collectors of saw palmetto that's featured here are Spanish speaking. But again, a thing, if you're working with a distributor, do your collectors follow the best practices kind of a thing? And then they're like, well, what are those? Well, here they are. So here's a brochure, and you can see we've got pictures of like, yes, harvest these color berries. No, do not harvest those berries. That kind of information is available here. One last thing I'll mention that we have as a resource at APA is our tonnage survey of select North American wild harvested plants. Gives you some great data just about, again, kind of the risks that you might be undertaking with your domestic supply chains, at least ones that are wild collected. We're trying to expand this survey into cultivated as well. And so if any of you guys out there are primary producers, farmers or such yourselves, please shoot me an email. So again, I'm going to wrap up now, and I feel like that was really quick, but I hope I gave you some good ideas of some places to go and kind of a general base of what is GACP and how you can help improve your supplier qualification and ingredient qualification programs. There's farmers all over the world that are growing the medicinal herbs that we want to put in our products. And this question again, not necessarily do you know your farmer, but do you know where your herbs come from? The closer you are to the source of your herbs, the less risk you will take on, just period. So there will be less risk the closer you are to knowing your supply and having that transparency. So again, thanks so much to Larissa and UNPA. And that will be it for my portion today. We'll send you along to all of the other wonderful experts we have. And I think up next, I'll stop sharing. Up next, we have Allison and Stan from QAI NSF. I'll turn it right over to them.
Thank you so much, Holly, and thank you, UNPA, for having Stanley and I today. My name is Allison McLeod, and I'm a technical scheme lead for Quality Assurance International, and I manage the organic scheme, and I'm joined by my colleague, Stanley Edwards, who is QAI's senior technical reviewer. QAI is one of the leading providers of organic certification services for organic products and handling operations and for our producers. As a USDA accredited certifying agent, QAI's programs verify organic integrity at each link of the product supply chain, helping to assure compliance with organic standards for ag producers, food processing facilities, traders, distributors, retailers, and ultimately for consumers. In the US, the USDA NOP is responsible for setting regulations for organic ag products that are either produced in the US or imported for sale in the US. In addition to setting requirements for organic ag products, or how organic ag products are grown, processed, and handled, the NOP also sets labeling requirements for these products. Today, we'll be touching on these requirements and certification best practices. Here, we're looking at the organic requirement facts. And as you can see, the very first thing on the slide is land requirements. So there's a 3-year transition period prior to organic harvest, where no application of prohibited substances can be taking place. Along with that, we have distinct defined boundaries or buffers to prevent contamination from adjoining land uses. No use of excluded methods, so no GMO seed or ingredients in the processed foods. Residue testing is, QAI must conduct periodic residue testing in organic products and is required to annually sample and test a minimum of 5% of its certified organic operations. However, testing is not for monitoring compliance. It's for determining a product, rather than determining, sorry. Testing is for monitoring compliance rather than determining if a product is organic. Certification is based on the implementation of an approved organic system plan, and annually qualified personnel conduct inspections. Some of these inspections will be unannounced. Certification decisions are carried out by the certifier, in our case QAI, and not the inspector, and no consulting is allowed during certification process.
Thanks, Allison. One of the things that Holly touched on was, know where your ingredients come from, and that's one of the aspects of organic certification that requires an audit trail from the source, essentially from the seed, all the way to the end use of the product. And where Allison talked a little bit about our residue testing requirements, when we get a pesticide hit, we use these audit trail requirements to track product all the way back to the last certified source. So being that we mostly certify handling operations, we are allowed and mandated by the USDA to pass on whatever records we got from, say, a facility, even a supplements manufacturer, that they got from their supplier, and pass that on to the next certifier down the chain that maybe certified another processing facility, and then they got their ingredients from a producer. So the traceability aspect makes it is essential for us in order to maintain organic integrity and to follow up on residues that might be detected at any level during the certification process. One of the this presentation really is going to be short for the scope of information that we really need to convey. And so it's really basic in that we wanted to make sure attendees understand some of the requirements and some of the processes that are required to be in place for organic certification. And for sure, SOPs and things like processes that define segregation and sanitation are in great part already in place because of FSMA requirements at a lot of facilities. Our presentation will cover some of these aspects, and then we'll go on to some of the product requirements. So what organic ingredients, what's required for organic ingredients, what's allowed as far as non-organic ingredients, and what's on the national list that could be of interest to you folks in the natural products industry. There's 3 labeling categories. I imagine a lot of operations here attending this presentation are already certified, so this could be old news to you. These are dependent on, the categories are dependent on how much of content is in organic content is in these products. That is based on a simple calculation that happens when you determine what labeling category you're going to be compliant with. And then there's a short section on best practices for obtaining and maintaining organic certification, very much similar to what you would have in a food safety system, where you have a team approach and an analysis of your process to determine where the risk to commingling and contamination might be in your process. So organic certification very much addresses the process as much as the product, but it really starts with determining where there could be risk within the processing that happens at your facilities, or even on a farm, say, and how to protect organic integrity. And Allison touched on that when she talked about land requirements, where farmers have to not only have buffer zones where there might be adjoining non-organic land to their farm fields, or even to a wild collection area. And in addition, they have to make sure that their equipment is clean. Like farmers have to make sure equipment is clean before they use it to harvest an organic product. So it's the same thing at the processing level, where a lot of processing plants are mixed use, and that a large amount of the processing that takes place is for non-organic goods. In an organic plant, you want to have an analysis essentially of your whole process to see that you're able to preserve the identity of the organic product. So it starts at receiving and storage, where you might want to have and need to have some segregation in your storage, and to all the way through the process where you have to have record of having cleaned lines before they're used for organic handling, clean containers for work in progress products, and well labeled areas for all of your staff to understand and be your own inspectors and find areas where there might be organic integrity that's been compromised. So this takes well-defined procedures, organic SOPs, color coding, and especially staff training. It's that your people are your best resources in maintaining organic integrity and also food safety. Some sanitation facts, materials that touch ingredients, of course, have to be approved for use in organic handling. So water would be one of those, but there's also some chemicals that are allowed, and those are on what we call the national list. So that would be section 205-605 of 7 CFR. And CFR meaning the Code of Federal Regulations. So chlorine materials are on that list. Peroxyacetic acid is also on the list, and hydrogen peroxide. And what's important when we talk about national list materials is that it's not just the fact that they're listed on the list, but a lot of them have annotations, have conditions for use that as an operation, you have to really study and make sure that you're following correctly, and use your certifier as a resource in understanding what the requirements are. Of course, if you use a certified organic material for sanitation, like vinegar or ethyl alcohol, that would be allowed without question, other than it has to have an organic certificate backing it. Because a material is not on the national list doesn't mean you can't use it, but it means that there has to be a process in place that's validated to ensure that organic ingredients are not in contact with the prohibited substance. So a lot of times the intervening event might be a rinse, or in the case of alcohol, it could be just simply letting the surface dry as an intervening event. And I talk about validated, meaning that when you develop your procedure and as you go into organic certification, you need to make sure that the action that you've done, that, like say, the rinse length has been validated through testing and through lit review. And this is where a lot of times organic consultants are helpful in helping you determine whether or not what you're going to do is going to be effective at protecting organic integrity. I talked a little bit about hot water and steam, also effective for cleaning and sanitizing, and usually okay without any question. Where water can't touch a certain piece of equipment in a process, say a mill or something like that, a product purge using organic product is perfectly acceptable after the equipment's been cleaned physically. The amount of product that goes through that machine, that the volume of the machine would be the minimum size of a purge that's necessary to maintain integrity in that equipment. Allison, you're next.
All right. What ingredients are allowed? So that really depends on the desired finished product claim that you're wanting to make. That actually drives the product composition. We have organic ingredients, which must be certified to the NOP or certified to an equivalency, equivalent international standard. For example, the USDA has an equivalency agreement with Canada and the EU. So ingredients certified to those standards would be okay. if we're looking at non-organic ingredients, ag ingredients must be on the national list, and that would be section 205-606 when the label claim is organic. For non-ag and synthetic ingredients, they also must be on the national list. Examples that would be applicable to you folks would be vitamins and minerals, and they're allowed as permitted in the FDA regulations, and Pullian capsules are also on the national list for made with organic products. And we'll take a closer look at the labeling claims. Here we have the labeling categories. First up is the 100% organic category. So products labeled as 100% organic must contain only organically produced ingredients and processing aids, excluding water and salt. So no other ingredients or additives are permitted. Products labeled organic must contain at least 95% organically produced ingredients. And again, that's excluding salt and water. Any remaining ingredients must consist of non-ag substances that appear on the national list of allowed and prohibited substances. And products meeting either of these labeling requirements may display these phrases. So 100% organic product can display the 100% organic claim, and organic can also display the organic claim, and both of these particular claims can display the USDA seal. The made with organic claim is for 70% of content in organic. And then the remaining 30% would come from allowed non-organic ingredients found at 205-606, or any non-organic ag ingredient produced without the use of prohibited methods. So non-GMO, non-irradiated, not grown sewage sludge. And made with organic products are not allowed to use the USDA seal.
So to figure out whether or not your product, say you have an encapsulated supplement, whether or not it will meet, say, a claim of some sort, it has to have a certain amount of organic content, and that's done through a calculation. So if it, a lot of times an encapsulated product will, the capsule itself might be too heavy for it to not be organic, and so when Pullulan recently got listed on the national list, that the use of the non-organic Pullulan capsules that would be allowed by the national list would only be allowed, it's annotated in the national list for only using as made with organic, with a made with organic claim. And a lot of that makes sense, because if it's not organic, a lot of times that capsule is just too heavy to make the cut of a 95% organic product. So if you're going to have an encapsulated nutritional supplement, you're going to need to have an organic certified capsule. And all of this is, it's really interesting, because we run into that quite a bit in our work, and we run these calculations a lot, and run across supplements that just don't make the cut, or they're just so close that it increases the risk of a product not being able to have the label that you thought you could design. So during the R&D process, it's really important to do the calculations correctly, and to really evaluate each ingredient that's going to go in there that's not organic, and to make sure that if it has to be on the list, that it's on the list, and all of these subtleties are covered. The calculation itself is fairly simple. It's the total sum of all of the organic ingredients divided by all of the ingredients, the total ingredients, and then the resulting percentage is rounded down. So even if you're at 94.9% organic, that is a 94% organic content, and can't use the USDA seal. It has to be labeled made with organic. A little subtlety in there is that if you have ingredients that contain more than one ingredient, so sub-ingredients in them, and some of them are not organic, so that means that you can only use the organic content within that ingredient as organic weight. So QAI has a form to fill out that does that math all for you. You just have to enter the quantity and the actual organic content of that ingredient. And that same form excludes water and salt that are added at your process. And it turns out that some of your products are liquid and have had water added upstream. We have another form where you can remove that water before you enter the product into the recipe sheets. Some best practices. I can't emphasize this more. It's getting food safety certification is a huge investment. Getting organic certification is a similar investment, maybe not as much, because if you've already got food safety certification, you probably have the team and the culture within your team are established to get it and to keep it. So think about creating an organic team where there's a lead person that's in charge that has the authority to move projects forward. And the team should have someone from production, someone from quality assurance, and someone from marketing. And we put marketing in there because there's so much riding on the labels and the expense of creating labels for products. So you want to make sure everything's in place before a label is created, and that it's created in a way that's going to be compliant. The establishment of an organic system plan can be done by the team, following what would be really similar to a HACCP analysis, from who the ingredient suppliers are going to be, whether they're duly certified, whether it's non-organic ingredients that are compliant, all the way through the process where we design systems to prevent commingling and contamination. So that involves creating organic SOPs or integrating SOPs for organic handling within your existing manuals, training all of the relevant staff to these organic SOPs, and performing internal audits of these SOPs on a regular basis to make sure that when you do have an organic audit, whether it's announced or unannounced, you're going to pass it with flying colors. So checking on your procedures, doing tracebacks, doing mass balance audits internally will pay off with a better, more efficient inspection, and with your assurance that your certificate will be granted with short delays right away after the inspection happens and the file is reviewed. The next thing, your stopgap here would be having really excellent communication with the certifier. So your organic lead, or if they're on vacation, somebody in production or QA should be able to drive projects forward and have a discussion with the certifier on issues that maybe they're not sure of. And the most important one of those would be anytime you implement a new process and anytime that you create a new label, that needs to be approved by the certifier before you implement it. And so a lot of this compliance should be real straightforward to you. It requires planning, and it requires ensuring that you have the right people in place and that everyone's informed about the organic standards and requirements. Our business development managers are here to help you obtain certification. They also have access to lists of consultants, maybe needed, often helpful. And of course, Lauren Browning and Marcy Burton in the gluten-free, non-GMO project and plant-based certifications can get you certified and get your labels approved before you move forward with your projects. Thank you very much. We got time for questions. I think maybe those are later.
Those are at the end. So we're going to move next.
Next speakers, I got Marcia Mole, who's Executive Director and Sales for Marketing for Dietary Supplements, CBD, and Hemp Markets for Food Chain ID, and Nate Ensrud, who's the General Manager of Technical Services, Certification, and Food Safety Solutions of Genetic ID.
Thanks, Stanley. Thanks, Allison. We really appreciate being invited by UNPA and all of the efforts from Larissa and Linda. Nate, if you could start sharing our slides, that'd be great. Stanley, I think you need to stop sharing.
I know, I'm trying to figure out how to do that.
There should be a little drop down bar right up
Pause
top.
share, stop share. There we go. It's all you.
Wonderful. Thank you. So on the next slide, just wanted to take you through a little history. So Food Chain ID was the first commercial lab to use PCR testing back in 1996 to test for GMOs. And that led to us working with industry to develop the non-GMO standard and then the non-GMO project verification program. We, to date, have actually verified more products than all of the other technical administrators combined. And we also offer other certifications, including USDA organic, as well as vegan, vegetarian, and plant-based. This is just next slide. On our other services and certifications, we offer regulatory compliance software platforms that could be very helpful to you. Next up, consumer perceptions and trends. Who cares about GMOs? Consumers really do care. With Pew's survey of US adults, 50% of them said that they felt foods without GMOs were much better for you than those with. And what does this mean from a sales trend perspective? Shown here from SPINS are trends for both the number of products that are sold with the non-GMO certification, as well as the sales trends. And what you'll notice is with just the non-GMO project certification, sales trends outpace the category 4-to-1. When the two seals are combined, organic and non-GMO, it outpaces it 7-to-1. Additional consumer marketing research. These charts show the consumer's familiarity with both seals and their meaningfulness. 61% are familiar with the non-GMO project and they find it highly meaningful, whereas 81% are familiar with USDA organic. Now I'm going to turn it over to Nate.
Thanks very much, Marcia. Marcia provided a great snapshot of how our consumers think about GMOs, organic products, and the health benefits communicated by these types of certifications or verifications. Now I want to dig deeper into the scientific and regulatory environment we're operating in. While many consumers would struggle to define what a GMO is, there has been a pretty strong scientific consensus for a while. However, that consensus is starting to shift in the face of novel gene editing technologies. In the simplest sense, a GMO is a plant, animal, microorganism, or any other organism whose genetic makeup has been modified in a lab. The first GMOs that we saw used transgenic technology to insert new genes into an organism, and were heavily focused on crops. For example, Roundup Ready strains of corn and soy. Newer GMOs are using more targeted gene editing technologies to make changes more specifically in single sites and are occurring in a much broader range of organisms. You think about why do companies genetically engineer crops? It's pretty simple: increased yield, decreased costs. Used to add traits like resistance to herbicides and other pesticides, as well as resistance to the pests themselves. So this is actually, as we talk about both GMOs and pesticides today, where you see considerations converge. In many cases, GMOs have been developed to allow broader use of pesticides. For instance, Monsanto developed Roundup Ready crops so that you could use more Roundup, which is also made by Monsanto. It's not always that simple, but the principle is true in many cases. However, when we think about quality programs, it's not always so simple that GMOs and pesticides go together. So going a little deeper here, this is a list of crops that have been genetically modified and are already in commercial use. There are even more that are being investigated and developed in research settings. For many staple crops, GMOs are used widely. For instance, in the US, the vast majority of soybean and corn crops are genetically modified. Now, let's talk a little bit more about this from a regulatory standpoint. Over the last several years, numerous states have been introducing legislation to require disclosure of the use of GMOs in food and supplement products. Federal law was enacted to bring this under a single framework that USDA would administer. And at the beginning of 2022, the National Bioengineered Food Disclosure Standard, NBFDS, went into effect. Evelyn's going to go into way more depth on the labeling implications. So we're going to focus more on how this dovetails into compliance programs and risk programs. So the law requires disclosure of the use of GMOs, sort of. There are pretty controversial aspects of this. One is that it focuses on the presence of detectable GMO DNA. And the second is that it uses a new term, bioengineered, which has a more limited definition. For any company making products where health and wellness is central to their brand, this brings a new challenge. We're moving beyond voluntary certifications and verifications like organic and non-GMO project and into compliance. If you haven't been specifically sourcing non-GMO or organic ingredients, this can be a really big challenge. We've been working with companies a lot in this space, and to avoid BE disclosure, you'll end up having to ask some questions or answer those if you haven't had to before. First question seems like it should have an easy answer. Is it bioengineered? Just look at the list of crops. However, what we see is that there are hundreds, if not thousands, of ingredients derived from GMO crops. So you might not be throwing corn kernels or soybeans in your product, but I'm sure you're probably sourcing some ingredient that maybe was derived from corn or soy. Maybe it was processed enough to remove the DNA, maybe not. Here's one example we run into. You have a vitamin premix, you figure it's a pure vitamin. There's no BE risk here, right? Maybe, maybe not. It's almost definitely not a pure vitamin because it's spray dried on a carrier. There's a dispersal agent, something else in there. Often those inputs, maybe it's maltodextrin, come from a cross source that could be genetically modified. That could be any input, and it's probably not obvious. So you figure, let's go get documentation from our suppliers that covers us on this. What we've seen, because that's the first place we thought we'd start when we're helping companies, is that very few, if any, ingredient suppliers have helpful documentation, or we're thinking helpful documentation, test results, validated refinement processes, or documentation of the source of the ingredient. So if you're able to get anything, I'm guessing it's a letter. And that letter probably says something like, this isn't bioengineered, no need to look here. In reality, this often means we're not sure either. So this lack of transparency in the supply chain when it comes to BE risks is really creating a challenge. So what we've seen for most companies that we're working with, the fastest and easiest path to compliance is a tool we're already using. It's testing. Supplement companies are actually really uniquely positioned. They've been better positioned than most companies we've been working with because they already have a well-developed ingredient and finished product testing program. So we're adding potentially GMO testing as part of this to avoid that BE disclosure. So we want to spend a little bit of time digging into what that type of testing program might look like. So this is where we'll bring GMOs and pesticides back together when we're thinking about testing programs. We talked about their shared history, and now GMOs are a more prevalent consideration for many risk mitigation or hazard verification programs. However, monitoring and managing risks from GMOs and pesticides are very different considerations. If you have GMOs in your product or coming from an ingredient, it's almost always a function of ingredient source. It's inherent to the material itself. So GMOs are a compliance risk for accurate labeling. And honestly, they're probably a consideration for almost any product given how many different crop-derived ingredients we have. Pesticides are very much a food and product safety risk, and their presence is a process issue with risks up and down the supply chain, especially for botanicals. That means separate testing programs, separate risk mitigation strategies. A GMO crop could be pesticide-free. A non-GMO ingredient may be contaminated with pesticides. So you really have to look at both separately. So let's take a deeper look at how we test for them. Marshall, you.
Thanks, Nate. There are two types of testing for GMOs. There is the strip test as well as the PCR test. Both are capable of producing results that are either qualitative or quantitative. Strip tests, they primarily provide a yes or no answer on the detection of GMOs. They're fast and cheap. They can often be done in the field and are used as a first screen, but they have limited applicability and they are primarily used for unprocessed materials such as seeds, grains, and leaves. Whereas the PCR technology must be done in a lab and it has a limit of detection of 0.01%. It's more sensitive in providing the exact percentage of GMOs that are detected, and it's applicable to a wider range of both processed and unprocessed materials. It's used for export to markets such as the EU, which have mandatory GMO labeling requirements, and in the US, it is required for both non-GMO project verification of food products, and the percent GMO must not exceed 0.9% per ingredient. So what is PCR testing and how does it work? It's a technique that amplifies or copies DNA billions of times. And the sequencing options include either broad spectrum assay or event-specific assay. The broad spectrum is used in many different GM crops, and the event-specific is a technique unique to one specific GM crop. So accurate test results require three things. First and foremost, having a representative sample. Two, proper sample prep. And three, the technical expertise to select the testing methods, especially when dealing with complex sample matrices. Another aspect to obtain accurate results when conducting testing for the presence of GMOs is during the extraction process. Number one, the DNA must be sufficiently intact. And two, the extraction methods need to be optimized for the specific sample type. These methods need to minimize degradation of GMOs to be successful, and the matrices of some finished products may have degraded DNA and as such cannot be amplified by PCR technology to test.
All right.
Next, I'm turning it back over to Nate.
Yeah, thanks, Marcia. I'm going to wrap up real quick, and I'm actually going to fly through these next couple of slides because I want to make sure Evelyn has time. She's going to go into some very new and relevant topics. So pesticide testing is something that we all should be familiar with if we're making any sort of botanical product. So just a reminder, there are thousands of pesticides that we might have to worry about. If there is not an established maximum residue limit, the EPA standard is zero tolerance, which means that you want to be very smart about how you approach testing for this. And at this point, I'd make a real strong push for anybody that's implementing or doing pesticide testing in botanicals to start with the standard, which is the USP 561 method. USP has done some very good work to narrow down the list to really focus on pesticides that are the highest risk for botanical products. That risk-based approach is something that many companies would want to do. USP has already done the work for you. So if you're doing custom program development, you should have substantial data behind why you're focusing on either a smaller list of pesticides, but otherwise rely on the standard and work with the lab that's going to help you develop that type of testing program. So with that, Marcia and I will wrap up. Hopefully we help provide a clearer picture of the world of GMOs and pesticides. With that, I will hand it over to Evelyn, who will bring us home talking about NBFDS in more depth. Thanks very much.
Okay, well, bear with me while I share my screen. And I thank you for joining me or sticking with me through this to talk about the labeling, which is something that a lot of people prefer to ignore, but it's really important because everything on that label is supposed to reflect the things that you have already done. And that includes this sort of steps that these previous speakers have mentioned. You're looking at the good agricultural practices and any certifications that you want for your products. And to focus now on the National Bioengineered Food Labeling Standard, I want to note that compliance with this standard is greatly helped by the steps that these other speakers have talked about. Now, the underlying legislation for this rule was signed into law on July 29th of 2016. It has become, there was some voluntary period for it, and now it became mandatory January 1st of this year. The law directed the Secretary of Agriculture to establish standards for disclosing bioengineered food to consumers. The statute defined bioengineered, which you've heard other people talk about a little bit, that it is food that contains genetic material that has been modified through in vitro recombinant deoxyribonucleic acid techniques, and for which this modification could not have occurred through conventional breeding and would not have been found in nature. So this law preempted various state laws that were aimed at giving consumers information on bioengineered and genetically modified foods. It also preempted these laws that other states had started. In particular, Vermont had Act 120 that they passed in 2014, and it was becoming effective and enforceable at the time that the national law was written, and that was done to preclude having this patchwork of state and other political entities with their own rules. The standard and the law allowed that the National Organic Program certification would be considered sufficient to make a claim regarding the absence of bioengineered ingredients in foods, and to be able to say not bioengineered, non-GMO, and other similar claims. Okay, so what does this bioengineered disclosure standard require? We've talked before with the previous speakers, and I've already mentioned that the definition says that a bioengineered food or substance has to contain the modified genetic material, the modified DNA in it to be considered bioengineered. Now, I happen to think that this bioengineered disclosure standard is exceptional because there are so many exceptions to what must be labeled by it. And we're going to start by looking at those. First, a food is not considered bioengineered and not subject to disclosure if genetic material is not detected. This does not mean that the product wasn't bioengineered. It just means that the DNA from, say, the bioengineered corn or soybean is no longer detectable. A food is also not bioengineered if it has an incidental additive that's present at the food at insignificant levels and does not have a technical or functional effect in the food. Nate had mentioned that sometimes dietary ingredients will have been spray dried onto maltodextrin. Well, can be, how do you interpret the incidental additive rule? Is there enough maltodextrin that it's too much to be incidental? But these are very important things you have to look at and analyze. And I will say that this standard is probably quite different than what most consumers who are concerned about bioengineered foods was looking for. And then let's just go on with more things that mean a food is not bioengineered. And one is that animals that are fed bioengineered feed do not become bioengineered themselves. The feed does not modify their DNA through an in vitro method. And also food certified under the National Organic Program is not a bioengineered food, which makes perfect sense. So we've noted that disclosure is required for foods that contain bioengineered ingredients if they are subject to other food labeling requirements under FDA regulations or under the Meat, Poultry, or Egg Inspection Acts. And again, disclosure is required, but there's a lot of exceptions. And here's some howevers as the exceptions. If a record shows that a food does not contain a bioengineered ingredient, it may not bear a disclosure statement. So this prevents you from being lazy and just overwhelmed by the difficulty that other speakers have mentioned of trying to figure out if your ingredients would qualify for the labeling. You can't just, for safety's sake, label the product as bioengineered. In some cases, voluntary disclosure is permitted, but it is not permitted when only an incidental additive is the source of bioengineering. This is, as I said, a very exceptional rule. Some voluntary labeling that is allowed is online disclosures and in catalogs, because the standard only requires that the disclosures be on product labels. I also want to point out that since there are no meat, poultry, or egg products that have been produced through in vitro recombinant DNA techniques, products that list meat, poultry, or egg ingredients first are not bioengineered foods. And this first, you note, has an asterisk that if water, stock, or broth is the actual first ingredient, then you look to the second ingredient and you'll find that if it's, meat, poultry, or eggs, this is not going to be a bioengineered food. More exceptions. If the presence of a bioengineered substance is not intentional, then the food is not bioengineered. And the allowance for inadvertent or technically unavoidable BE presence is up to 5% for each ingredient. It's going to be interesting to think how you would inadvertently know that you're under 5%. But I mean, I think that what that does is invites companies to perhaps cut expensive non-GMO or bioengineered ingredients with a small percentage of others. But maybe I'm just becoming too skeptical after seeing so many C of A's over the years. Well, so even with so many exceptions to what the standard requires be disclosed as a bioengineered ingredient, you cannot use terms such as not bioengineered just because disclosure is not required. To say something is not bioengineered, you need to have absolute showing that it was not, and that's where the non-GMO standards and the organic standards are very helpful. So who must comply with this rule? Food and dietary supplement manufacturers with annual receipts of at least 2.5 million, food importers, and food retailers. But restaurants and other food service businesses, and airlines were specifically listed there, just in case you're wondering what they've put before you, if they do serve you food these days. But those food service groups are exempt. So how do you even begin to comply with this rule? First, you have to know what ingredients that you use may have been derived from bioengineered crops. And you've already seen this list in a more beautiful pictorial way than I'm providing it. But this is a list that the Agricultural Marketing Service keeps of products, agricultural products that are allowed in the US that have been genetically modified. And I just want to point out the usual suspects of corn, soybean, and sugar beet, which are ubiquitous in US foods. Another one that I just thought was interesting is the pink flesh varieties of pineapples. And it could make sense that a pineapple that's pink would be genetically modified and might not be found in nature. And another one that I find interesting is the only bioengineered animal that's permitted to be grown in the US, and that's the Aqua Advantage salmon. So we've talked before that a product is not bioengineered, even if it was, if there's no detectable modified genetic material. In that case, disclosure would not be required. And the final rule for this standard mentioned a number of studies that demonstrated that very few foods made with bioengineered ingredients have detectable DNA in them. However, the amount of DNA that may be detectable can vary and is dependent upon the processing or cooking, the times, the temperatures, and many different things, how dry it was, how moist it was. So that leads us to how are you ever going to know? And we had this lovely presentation prior to mine about the detection of the DNA, which can be done. But I've never seen a certificate of analysis where they've noted that they've done such testing. I have seen certificates of analysis with that dubious attestation that bioengineered ingredients were not used in the production of this product. There were also a number of validated methods that can be used for detection of recombinant DNA, as you've already heard. USDA published guidance documents on this sort of testing. I've given you a link there in handouts that I hope that you'll receive so that you can look at those yourselves. They also published validation of those tests and validations of refining methods and processes that could enable you to not have to disclose a bioengineered ingredient. And excuse me. Now, pardon me, my next few slides I'm dedicating to Larissa Pavlik, because anyone that has talked with her much or listened to any of her presentations will know that she's a huge fan of record keeping. And so regulated entities must maintain records to demonstrate compliance with this standard. The records can be electronic or paper, but they must have sufficient detail to be readily understood and audited by the Agricultural Marketing Service. The records must be maintained for at least 2 years beyond the date that the food or food product is sold or distributed for retail sale. I'm sorry, I'm running a bit behind. If a food is on the list of bioengineered foods, even if you're using organic, you still have to keep records. So if you're using corn, soybean, or sugar beets in particular, any of those other things on that list, you must have records to show that it's not bioengineered, because the chances are that it could be. There's also the situation that if you receive an ingredient that has a bioengineered food disclosure on it, even if that food is not something that is on the list that the Agricultural Marketing Service created, you have to maintain records about that and figure out why did they so label that product as bioengineered. So what are your records? The typical things, supply chain records, invoices. The supplier attestations can be records. I'm not sure that they'd be sufficient, but they are records. The third-party certifications, laboratory testing results, and other validated processes. Okay, so then what? What's enforcement? There is no indication that FDA is going to be enforcing this rule. It is not an FDA regulation or standard. It is from USDA. And I looked, and so far they've not made any notes about it in their compliance manuals. On the USDA web page under BE frequently asked questions, they note that for purposes of compliance, the Agricultural Marketing Service intends to enforce the standard only at the retail level. And I've again given a link so you can read about that. There is another means of enforcement, and that is that anyone who has knowledge of a possible violation can send a written statement to the Secretary of Agriculture, who can then determine whether or not to make an investigation. Then how do we disclose? First, you can just have text on your label, either on the front panel or on the information panel, which usually has the nutrition facts box on it, that something is a bioengineered food or contains a bioengineered food ingredient. Can also use one of the happy little symbols that USDA created. On the left there is for bioengineered, and that would go on that pink pineapple and most other products that contain genetically modified or bioengineered genetic material. There's also derived from bioengineering symbol that is on the right, which as far as I can tell is only used for voluntary disclosures when it's not required, but you know that some of your ingredients were derived from bioengineering, but the amount is small or the DNA is no longer detectable. It's also possible to disclose by an electronic or digital link, such as a QR code. And this is very unique in this standard, in that this method does not use the word bioengineered anywhere on the label. And it also happens to be the first time that a federal rule allowed for use of QR codes. So it's kind of interesting, and you can read more details about it in the handouts. You are also permitted to disclose the presence of bioengineered foods via text message. On your label, you have to have a note to text and give a command word to the number for bioengineered food information. And it has to send an immediate response to the recipient's phone or mobile device. And there's many other rules about this we don't have time to go into. They can't market to consumers via that text message. And I encourage you to know those ins and outs. Now, the last thing I want to mention is that there has been a lawsuit filed regarding this standard. It was originally filed in July of 2020, and for some reason I've not been able to ascertain, was refiled in November of last year. And with this, a group of organic food companies and advocates filed a motion for summary judgment asking a California federal judge to declare USDA's National Bioengineered Food Disclosure Standard invalid. Specifically, the plaintiffs state that the standard falls short of fulfilling the promise of meaningful genetically engineered food labeling as was intended by the original law. And that also this standard excludes most genetically engineered foods from disclosure. As I said, this is a very exceptional standard. As far as that lawsuit goes, there's no new news as of last night. Maybe something's happened since we've been talking today. So meanwhile, you have to do your due diligence, keep your records, and comply with the rule. And with that, I'll say thank you for listening, and UNPA, thanks for having me. And I don't know if we have any time for questions, but I'll give you back the screen.
Thank you. All right, if everyone that stuck around, I appreciate it, and thank you, thank you. We are out of time for questions, and I want to respect your time, but I hope the information was valuable for each of you. So you can contact us directly, Linda or myself, and we will distribute those questions, or you can contact each of the speakers directly. They have a lot more information that's available on each of these topics. Again, trying to carry that from agricultural up to GMPs. And our next webinar will either be What the Spec, which is going to help us understand what does identity, purity, strength, composition mean. And then we also have a GMP webinar that we're working on as well. Can't decide which order I want to use that. But one of the hot topics that is on the plate is we have a lot of companies that are scaling up related to volumes, and we have some great resources to help you to scale up without having mass loss due to either inefficiencies of the production line or purchasing the wrong facilities. So that's another one that's hot on the plate. We have only a few minutes, 2 minutes. Does anybody have a hot pressing question that they'd like to throw at the audience, or we may close out and use the internet for those?
I would just like to say hi to Marcia Mull. I worked with her back in the day in Perigo. This is Will Walkup. So nice to hear your voice, Marcia, and see you again.
Welcome.
You will. Good to see you, and thank you.
Yep.
All right, Linda did not receive questions. I did not see any come into the chat window. So with that, I want to thank everyone again for attending. Appreciate all your time. I know we all sit through tons of webinars and our Zoom burnout is high. So I appreciate you sticking around for this hour and a half. Lauren, did you have anything in the last moments? Or?
Just a thank you to you, Larissa and Linda, for organizing this, and to all of the speakers, presenters. Such an important topic, a lot of confusion and a lot of emotion. So this was a valuable contribution to a better understanding of what will continue to be a contentious issue for years to come. So many thanks. I think this was a very valuable morning.
If you have any questions regarding your supply chain, let us know. I'd be happy to help. And our next training will be coming up this summer related to preventive controls. And to everyone else, thank you for your time. Appreciate you.
Thank you.
So much, UNPA.
Thank you, everyone.
Everyone.
Bye.
Thanks to my speakers. You're awesome.